So I am here to show you today your experimental setup, and for those of you who are absent, I'm here to collect your data for the molar volume of a gas lab that we're going to do. So let me start talking you out with the stuff we're working with. So here's our reactants. We got magnesium solid and hydrochloric acid. So we're going to use 6 molar HCl. And I'm going to put about 10 milliliters of it into our collection tube. The amount doesn't really matter for the HCl because we are going to purposefully add it in excess. And then we're going to react that with solid metal magnesium. So here's our piece of solid metal magnesium. It's right here, this one. I've looped it onto a copper wire. The copper wire is not important. Copper will not react with HCl. So it's just being used to literally just hold the magnesium in place. So the magnesium I have already massed out. It's 0.057 grams. For those of you who are going to do this experiment on your own, you do not have to use this number. Please use your number. Don't use mine. This is just for the people who are absent. All right, so what we're going to do is we're going to take these two things and combine them and figure out what they're going to produce. Obviously, we know that this is the molar volume of a gas lab, so it's probably going to make a gas. Duh. And what are we going to use to collect our gas? This thing right here. This is called a, wait for it, gas collection tube, appropriately named, yes. All right, so basically this kind of thing is like a cross between a burette and a super long test tube. So it's got graduations on it, just like a burette would, so you're able to see the numbers, the amount of stuff you're making. But it's closed on one end, just like a test tube, open on the other. So we're going to take our reagents, put them in here, and then we're going to collect this gas over water. So think about the things that affect gases. We've got N, your number of moles, how much stuff you're starting with. V, the volume of the gas that you're making. Temperature, T, temperature of the room, temperature of the surroundings. And in here is a little bit of a colder day, so I'll make sure I get that temperature for you. And then lastly, the pressure. So I will use the barometer in our classroom to collect the atmospheric pressure for you. But keep in mind also, we're doing this gas collection over water, so we also have to take into account the pressure of the water vapor in this reaction. So that's going to require a little bit of calculation on your part. So let's go back to this reaction for a second. We're taking a solid metal and we're going to react it with an acid. Oh man, we got to think back to acid-base reactions. Okay, metal reacting with an acid should produce hydrogen gas coming from the acid and then a salt. You got your metal and you got a non-metal. You got chlorine and anion. So together those things are going to make an ionic salt that stays dissolved in solution. So we're going to take these two things, put them together, Mg and Cl. Oh God, making ionic compounds. What? The thing that I told you was like one of the most important things you were ever going to learn comes back to haunt us here and even in AP Chem. Oh my God. All right, so Mg plus Cl, put those things together. Boom, 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 boom. MgCl2. Okay, got one. MgCl2, and this thing is going to be aqueous, stays dissolved in solution. Then the other thing we're going to make is hydrogen gas. So hydrogen gas, how we're going to write that formula? It's a Hofbrinkel, so we better write it as H2. So plus H2 gas. All right, take a second, look at that equation. Is there anything wrong with it? Oh yes, absolutely, unbalanced, ew. How do we fix it? Add 2 right there. Okay, so here's our reaction equation that we're working with. Now let's figure out how we can set this thing up. So I already told you that I massed out our magnesium. That's important for us to know. So what we're gonna do inside our gas collection tube is we're gonna add our HCl to it first. So I'm gonna carefully add our 6 molar hydrochloric acid to the gas collection tube. Avo's trying to get out. She really wants to be involved in this video. All right, there we go. All right, so hydrochloric acid is more dense than water. So what I'm gonna do is I'm going to very slowly and carefully add my DI water on top of my acid. I basically wanna create 2 layers inside my gas collection tube. when I put in my magnesium ribbon, I don't want it to react with the HCl until I'm ready to start collecting that gas. So by slowly adding the water to the gas collection tube, I'm causing the HCl and the DI water not to mix. So notice I'm doing this at an angle. This is going to help them stay a little unmixed. And I'm just very slowly going to add this in. I'll create 2 layers, and then I'll be able to add in my magnesium without it starting to react. So this is going to take me a second because, like I said, I'm doing it slowly, but you want to make sure that you fill it all the way up to the top. Okay, so 6 hours of me realizing I am not wearing any gloves later. Put them on. I have my gas collection tube completely filled to the very top with water. I'm gonna put my magnesium strip inside. So the hydrochloric acid is at the very bottom of the tube. Water is up at the very top, so it's not reacting yet. You want to make sure you don't let any air get in because all of your gas needs to come from the hydrogen that you're going to produce. So you're going to cap this completely with your finger, and you have to very quickly and carefully invert it so that way it goes into your large beaker of water. So this takes a little bit of practice. Carefully and quickly, all the way invert it, put it at the very bottom. Okay, so cool thing about our iPads is that they do not have a lot of space, and since I record a lot of videos for you guys, I forgot to delete some before I started making that video, and it totally ran out of space. So here is your gas emission tube. I've inverted it completely. You can see it reacting down here at the bottom, producing a bunch of hydrogen gas. So we need to let this sit for a while. Make sure we get out all the hydrogen gas that we possibly can. And then I am going to put it into a new tank of water where I can equalize its pressure and its temperature, and I'll show you guys what that looks like in the next step. Hi everybody. So next step, what we're going to do is we're going to take our gas that we've produced here in our lovely gas collection tube, and we are going to equalize the pressure. So the pressure inside is going to have to be equal to the pressure outside, and the pressure outside is atmospheric pressure. I just went and measured on our barometer. The atmospheric pressure in the classroom currently is 758 millimeters of mercury. So we'll have to do a quick conversion to get that to atmospheres when we start doing calculations. So I've let this sit for a couple of minutes. I'm trying to let the hydrogen gas equalize in temperature with the temperature of the room as well. But I'm going to transfer this over to a different tank of water. Let that sit and equalize the pressure and the temperature out one more time. And then I will plug in the temperature to the absence slides as well. So push this back so you can see what I'm going to do. Okay, so I'm going to take the gas tube with all of our lovely hydrogen gas in it. Okay, and then I have to cap it again with my finger so that way we don't lose any of our gas. So I'm going to cap it real quick, take out the copper wire because I don't need that anymore. And then very carefully put it into my new tank of water. Okay. All right, so what we want to do is we want to raise and lower this until the water level is equal on this tank and the water level inside of our tube, because that's when we know our pressures will be equal.